Now, if we recall the problem that we discussed earlier, while we were discussing about uh, the problem of combination and permutation, and permutation in particular, we were trying to find out how many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered a contest. Now let's say instead of 100 we have 10 people, and the prize, there are 3 prizes. So in that case, n is equal to 10, and since there are 3 prizes, r is equal to 3. Now we have to look at in how many ways we can arrange that, all these 3 prices. So let's say for the person winning the first prize, let's say this is second, and then this is third. We'll give $20 to this, $10 to this, and 5 to the person winning the third prize. So here the order matters. Therefore, we know that NPR in this case will be equal to 10P3, which is equal to 10 factorial divided by n minus r factorial, which will be 10 minus 3, 7 factorial. So this will be equal to 10 times 9 times 8 times 7 factorial divided by 7 factorial. So this and this will cancel out. What we'll get is 720. Now, to get the idea of combination, let's say we have these 10 participants. Again, these 10 participants in the but in combination, a particular case of combination, what we're saying is that out of all these 10 participants, those that top 3 whose performance is among the top 3 individuals, each of them will get the same price. Let's say each of them will get $20. All you have to do is that you have to be eligible to pass this cutoff to be among the top 3. So in that case, what we'll have is that will be equal to 10C3, which is equal to 10 factorial divided by 10 minus 3, which is 7 factorial, times r factorial, which is 3 factorial. So what we'll get is 10 times 9 times 8 times 7 factorial divided by 7 factorial times 3 factorial. So this and this will cancel out. This will be 10 times 9 times 8 divided by 3 times 2 times 1, which is 6. 3 times 2 times 1. So we'll have 3 times 3 is 9. 2, 4. 2 times 4 is 8. All we are left with is 120. So the reason there is this much of difference in the permutation, we got 720, and here we have 120. In permutation, we care about each and every individual there, like in how many ways we can represent those 3 prices. But here we only care about the cutoff, and rest of it doesn't matter. So that's why there is this much of difference. So that was about the difference of the difference in the permutation and the combination. And secondly, we also discussed like the order matters, and if let's say S is equal to 1, 2, and 3, and one of their permutations will be, let's say, 1, 2, and it's different than 2 and 1. However, so these two are different. However, in this case, this is 2 and 1. So 1 and 2 is different than 2 and 1. However, in the case of combination, 1 and 2 and 2 and 1 both are the same. So we only have one of these. So that's why in that case we'll get the count of combination is less. So that was all about the difference between the permutation and the combination.